Hello everyone. Welcome to our course on GaussDB, operations and maintenance capabilities. This course will introduce daily O&M operations and processes by discussing the function, constraints of using platform and how to manage, cancel the management for, start, scale, stop, and delete instances on the GaussDB management platform. This course mainly consists of 6 parts: platform introduction, function overview, basic instance management, instance upgrade, instance DR management, and instance monitoring and alarm reporting. First of all, let's take a look at platform introduction. As shown in the figure on the left, this is the architecture of the platform. The platform consists of 3 layers. First, it's the open ecosystem. It serves as a tool for GaussDB management and provides unified user experience on and off the cloud. Next, it provides basic and intelligent O&M capabilities, especially the intelligent O&M parts, including circle diagnosis and tuning, intelligent inspection, execution plan binding, and so on. It's all about creating a self-monitoring, self-diagnosis, self-tuning, self-recovery, and self-protection platform. You can log in to the Gauss management platform using an authorized account to view the following pages. On the instance overview page, you can view the managed DB instances, health status, and alarm monitoring information. After clicking the target instance on the displayed page, you can perform O&M management operations on the instance, including backing up, restoration, parameter management, log analysis, and other intelligent O&M operations. You can also configure execution policies. Next, it's the function overview. Let's look at the basic management functions of the GaussDB management platform. As a management and control platform for O&M security, the GaussDB management platform provides comprehensive security protection with fine-grained access control and the separation of users, roles, and user groups. To be more specific, the basic management functions are as follows. User management. Administrators can add, delete, lock, and reset passwords for common users, and bind users to instances and user groups. Like the user group management, you can add users to a user group and assign a unified role to the entire user group. A user can be added to multiple user groups at the same time. And the role management. You can define custom roles and assign particular permissions to them. Also, the fine-grained permissions are supported. In addition, the platform provides active user sessions management and API for authentication and weak password verification to ensure security. In terms of instance management, you can manage, start, stop, and reboot, scale up, manage the upgrade of, manage alarms for, manage inspection tasks for, and manage the DR for instances on the GaussDB management platform. As shown in the following figure, the GaussDB management platform interacts with users through the management console and interworks with the agent on the instance through GaussDB microservices for you to manage, control, and perform O&M operations on instances. It also provides northbound function API and alarm interconnection to open up existing capabilities. Later, we will describe detailed operations and procedures based on the O&M functions of each instance. Okay, then it's basic instance management. After a DB instance is created and its status becomes normal, you can manage the instance on the GaussDB management platform. As shown in the figure on the right, you need to add the host running the instance to the GaussDB management platform. Before managing an instance, you can enter any management IP address of the instance node, click Check Instance Nodes, and check whether the host has been added to the GaussDB management platform. If the host status is online, the host has been added to the platform, and the instance can be imported. If the host status is offline, the host has not been added to the platform, and the instance cannot be imported. After all hosts are online, you can enter the instance name, administrator username, and administrator password, and click Submit to deliver the request for managing the instance. After an instance is managed, you can perform OM management operations for it on the GaussDB management platform. On the GaussDB management platform, you can also cancel management of an instance that has been imported and managed. As shown in the figure above, you can locate the instance you want to cancel the management for, choose More, Cancel Management in the Operation column, enter the administrator password in the displayed dialog box, and click Yes to cancel management of the instance. After you cancel the management for an instance, you also need to remove agents from the nodes and delete historical information about the instance on the GaussDB management platform. The GaussDB management platform allows you to stop, start, and reboot managed DB instances. Similarly, you can locate the target instance and choose More, Stop to stop the instance. For an instance that has been stopped, you can choose More, Start to start the instance. You can also locate an instance and choose More, Reboot to quickly reboot the instance. The GaussDB management platform allows you to quickly delete managed DB instances so that you can reclaim hardware resources used by these obsolete instances. You can locate the instance you want to delete and choose More, Delete. Be careful, instance deletion is a high-risk operation, so you need to confirm the deletion in the displayed dialog box. As data volumes increase, database performance and storage gradually become a bottleneck. In this case, you need to add nodes to improve the DB instance performance and storage capabilities. GaussDB supports instance scaling by adding nodes. During instance scale-out, only the CN on DN will be added. The number of other components will remain unchanged. The table below shows common database scale-out solutions. For example, if 9 nodes have been deployed initially, the number of nodes to be added each time must be a multiple of 8. The etcd nodes in the arbitration AZ will not be added. For eventual consistency, each DB instance can contain up to 128 shards and 257 nodes. For strong consistency, each instance can contain up to 32 shards and 65 nodes. For details, see Administrator Guide. Instance scale-out consists of 2 phases: node addition and data redistribution. During node addition, there is a time window, which is in minute, for locking the DB instance. In the time window, DDL on DCL operations are not allowed, but the DML operations can still be performed. Data redistribution occupies some I/O resources, and the following circle statements are not supported, like create database, alter database set, create tablespace, drop tablespace, alter tablespace. To be more specific, if you look at the timeline of instance scale-out, you can see that the online scale-out involves 2 phases: node addition and data redistribution. In the node addition phase, the nodes can be added within minutes. The time required for data redistribution depends on the number of nodes to be added and baseline data volume. Generally, data can be redistributed within hours. During node addition, new CN on DN are installed, metadata is synchronized, and the CN on DN are started. During data redistribution, baseline data is migrated, incremental data online is migrated, and metadata is switched over. To synchronize metadata to new DN on CN of a certain table, you can perform the following operations. First, synchronize basic metadata, including databases, schemas, and tablespaces. Second, synchronize general metadata, including user tables and functions. Third, create a node group, which is the new cluster after scale-out. Fourth, switch the installation group to the new node group after the metadata synchronization is complete. Please note that the purpose of metadata synchronization is to prepare for subsequent data redistribution. Now, let's talk about the procedure for scaling out an instance on the GaussDB management platform. On the Instances page, click the DB instance you want to scale out. The basic information page is displayed. In the DB information area, click Add in the Nodes field. The Add Node page is displayed. On the Add Node page, select the number of nodes and management addresses. The number of management addresses must be the same as the number of nodes to be added. The AZ distribution of management addresses must comply with the deployment scheme. Check the displayed message Add nodes during off-peak hours, because this operation will lock tables and block services, and select I have read and understand the risks. Click Next. The Details page is displayed. Confirm the details and click Submit. The DB instance is being scaled out if its status becomes Adding Node. Please note the following precautions when you scale out an instance. During instance scale-out, only the CN on DN will be added. The number of other components will remain unchanged. Adding nodes will not affect the distribution of components. An instance deployed in active standby mode does not support scale-out. Scale-out is not allowed for instances with faulty nodes. Add nodes during off-peak hours, because this operation will lock tables and block services. Before instance scale-out, ensure that the remaining available space of all DN is greater than the maximum size of the table space on the DN. Next, let's talk about the instance upgrade on the GaussDB management platform. GaussDB supports in-place upgrade, gray upgrade, rolling upgrade, and hot patch upgrade. GaussDB upgrade may result in system table and data table changes, process restarts, version compatibility risks, and service interruptions. The table on the upper right compares different upgrade methods based on the service downtime and risk levels. For in-place upgrade, after a physical file is backed up, you can perform binary upgrade and then update and adapt system tables in the file, and services will be interrupted for 30 minutes. For gray upgrade, you can use circle statements to update the system table online, and then perform binary upgrade, and services will be interrupted for 10 seconds. For rolling upgrade, you can perform the upgrade based on the number of DN shards, or by AZ. Services will be interrupted for 10 seconds during the switchover of CN, or the primary DN. The upgrade of the kernel can be a minor version upgrade, or major version upgrade. After a minor version upgrade, a full backup is not required, and the kernel GUC parameter template remains unchanged. For minor version upgrade, you can use in-place upgrade, gray upgrade, rolling upgrade, and hot patch upgrade. After a major version upgrade, a full backup is required, and the kernel GUC parameter template is changed. Therefore, the major version upgrade does not support hot patch upgrade. On the GaussDB management platform, perform the following operations to perform an in-place upgrade. Locate the instance to be upgraded and click More. Upgrade instance in the operation column. Select In Place for Upgrade method. Select the target version for the upgrade, and click OK. Since there is an observation period for a gray upgrade, the platform supports the following two actions for performing a gray upgrade. Auto commit. All nodes are upgraded at the same time. During the upgrade, services will be interrupted for about 10 seconds. Another is rolling upgrade and commit. The upgrade consists of rolling upgrade and commit phases. In the rolling upgrade phase, you can upgrade the instance by AZ, or roll back an upgraded AZ. After nodes in all AZ are upgraded, you can test services on the instance. In the commit phase, you can commit the upgrade, and rollback is not allowed after the upgrade is committed. On the GaussDB management platform, perform the following operations to perform a gray upgrade. Locate the instance to be upgraded and, in the operation column, click More, Upgrade Instance. In the displayed dialog box, set action to auto-commit, and select the target version for the upgrade. When selecting actions for a gray upgrade with an observation period, you can select auto-commit, rolling upgrade, commit, or rollback. For a gray upgrade, you can select rolling upgrade for action, select the AZ to be upgraded, and select the target version for the upgrade. After all AZ are upgraded, you can select commit for action to commit the upgrade, and upgrade the DB instance. If an exception occurs during the rolling upgrade, roll it back. Next, let's have a look at the instance DR management. On the GaussDB management platform, we provide a streaming DR solution. This solution leverages database log replication to establish DR solutions with multiple intra-city data centers and remote data centers, achieving high reliability. The streaming DR management functions include establishing a DR relationship, viewing the DR status, DR switchover, promoting a DR instance to primary, and removing a DR relationship. The DR drill function is under planning. We will continue to illustrate these functions in following slides. Establishing a DR relationship refers to the process of configuring the DR database instance information for the primary database instance and waiting for the DR database instance to be connected for full replication. After the DR instance is created, streaming replication is established between the DR instance and the primary instance for incremental log replication. Up to now, a DR relationship is created between the primary and standby database instances, and service data can be synchronized. To create a DR relationship, you can click Create DR Relationship on the page shown on the right. Configure DR information and complete the creation. Please note that the data and configurations of the standby instance will be reset to ensure consistency with that of the primary one. After the DR relationship is set up, on the management page, you can view created groups, perform switchovers for DR instances, promote an instance to primary, and remove DR relationships. Click the target DR group on the page showing details. You can view basic DR information, RTO, RPO, and status metrics, including shard log gap of DR instance, flushing rate of shard logs in DR instance, size of shard logs to be replayed in instance, and replay rate of shard logs in DR instance. On the DR management page, you can perform a switchover to exchange the roles of the primary and standby instances in a relationship. The original primary instance becomes standby 1, and the original standby instance becomes the primary one. The new primary instance will function as the service access point. A DR switchover does not remove the relationship. After the switchover, a full backup is automatically performed on the original DR instance. After primary instance breaks down, you can promote a standby DR instance to an instance containing the primary DN, so that the instance can provide services for external systems. After the instance is promoted to primary, the previous DR relationship becomes invalid. To remove a DR relationship, you need to remove the maintained peer information from the primary instance. After a relationship is removed, you can create a new DR relationship for the primary instance. You can perform a DR drill test based on the current functions. The procedure is as follows. First, prepare 2 available instances. Second, create a DR relationship between them. Third, simulate a critical fault on the primary instance. Fourth, promote the standby DR instance to the primary instance to provide services. Fifth, repair the primary instance and remove the DR relationship. Sixth, re-establish a DR relationship. Finally, perform a DR switchover to restore the initial DR relationship. At last, let's talk about the instance monitoring and alarm reporting functions. On the GaussDB management platform, alarm statistics are provided on the real-time alarms and historical alarms tabs. Real-time alarms refer to the alarms of the platform itself and all the instances that have been managed on the platform. Historical alarms refer to the alarms that have been handled and the platform automatically retains or clears historical alarms based on clearing configurations. An alarm on the platform consists of basic information, alarm reporting details, and fault analysis information. Alarm basic information includes the alarm ID, alarm name, alarm type, monitoring target, and instance name. Alarm reporting details include alarm reporting time, alarm severity, alarm description, alarm duration, node IP address, and notification status. Fault analysis information includes possible causes, alarm impact, and suggestions. O&M personnel can quickly locate and handle alarms by checking the provided information. The GaussDB management platform allows you to send alarm information to northbound services over interconnection protocols such as SNMP, SYS, LOG, and HTTP. O&M personnel can configure alarm templates to customize the alarm content and data to be sent so that they can receive notifications in a timely manner. On the GaussDB management platform, monitored instances are displayed in a list. You can view basic metrics of each instance, including the CPU and memory usage. In addition, dozens of monitoring metrics about hardware resources, instance status, and database performance are provided to further facilitate status monitoring and management. The performance metrics are also displayed. You can view details about all monitoring metrics of the selected instance. Metric categories include CPU and memory, disk and storage, network, connections, workloads, locks, synchronization status, and process resources. Okay, let's review the course together. This course described the basic management functions: instance management, instance upgrade, instance DR management, instance monitoring, and alarm reporting on the GaussDB management platform. We also introduced O&M operations in kinds of scenarios. We hope you can have a deeper understanding of the management platform. Thanks for your watching.